All right, this is part 3 of section 8.3. This is the last little topic we do in the course, and we're going to talk about how to rewrite a repeating decimal as a fraction. Now, you know, if you see this bar on the top, which trivia is called a vinculum, if you see this is the same thing as 0.77777, so on. The bar indicates that that part repeats. Right here, 0.09 with a bar over it. This would be 0.09090909. That's the part that repeats. Now, what they want you to recognize is that this is 7/10 plus 7 100ths plus 7 1,000ths, and so on. Okay, and they want you to recognize that this is a sequence that it will converge to something. You can use the formula we had. All right, now why am I saying the book wants you to do that? They want you to recognize that that's not the most practical way to get these things done. Okay, now what I'm going to do here, you're probably not going to find the book, but it is what I think the easiest way to get this thing solved. Okay, I want to rewrite this as something. So I'm going to say, all right, my x value, the thing I'm looking for, is another way of rewriting 0.7 with a bar on it. Okay, I'm leaving myself a space up here. Now, why did I do that? Okay, first of all, ask yourself how many decimal places you have repeating. Here I have 1 place repeating. Here I have 2. This one I have 3. I have 1 repeating digit. So multiply both sides by 10. Because there's 1 0, and however many digits you have repeating, you want to multiply by a 1 with that many zeros. So 1 repeating digit, I'm going to multiply by 10. 2 repeating digits, I'll add another 0, so I have 100. 3 repeating digits, I'll add 3 zeros. I'll have 3 zeros. So however many digits you have repeating, you want 1 with that many zeros after it. If I multiply the 10 times x, I have 10x, and I'm going to write it above here. If I multiply 0.7 repeating by 10, then I get 7 point, and then I still have 7 repeating, right? Okay. Now what I'm going to do here is I'm going to subtract these. I can do this. If this equals this, then I'm essentially subtracting the same value from each side. So if I subtract this, I get -1, and this will be negative. If I add these together, 10x minus 1 is 9x, is equal to. Now look what happens here. The 7 and the 0, 7 minus 0, that's a 7. And then what's going to happen over here? I have 7s out forever. And if I go and I subtract those, all of those 7s out to infinity are going to cancel out. So I really just end up with 7. Now divide both sides by 9. And your x value is 7/9. 0.7 repeating is 7/9. You can use your calculator to check this. If I do 7 divided by 9, I get 0.7 repeating. It rounded that last digit. So you can see that this is the same. If I do the conversion, it's going to give me 7/9. Okay? Do the same thing here. I want to convert 0.09 repeating to a fraction. So I'm going to say x is equal to 0.09 repeating. Now I have 2 decimal places repeating, so I am going to multiply both sides by 100 because it's 2 decimal places. I'm going to 1 with 2 zeros. So this gives me 100. X is equal to. If I multiply this by 100, this decimal point moves over 2. So I'll have 9 point, and then I still have 0, 9 repeating. Now if I subtract these, just like I did above, the 0.9s cancel out because they go out to infinity and they match up to infinity. 100 minus 1 is 99. X is equal to 9. Divide both sides by 99. And you get x equals 9 over 99, which is 1/11. Divide 1 by 11. And you can see that you get 0.9, and that repeats. Again, they rounded right there, that last digit. So you can see that these are equivalent. Okay, and if you take that and you tell it to convert it to a fraction, it will give you 1/11. One more problem, the last one in the entire course. This time we have 3 decimal places repeating, so we are going to multiply by 1,000, a 1 with 3 zeros after it. So I do x equals 0.123 repeating. If I multiply this by 1,000, 1,000x equals, this is going to move it over 3 places, so I have 1, 2, 3, but then I still have 1, 2, 3 repeating. If I subtract, the 0.123's cancel out that repeating part, and I end up with 999x is equal 123. Okay, now divide both sides by 999, and you get, so 123 over 999, I believe top and bottom are divisible by 3. If I divide this by 3 and this by 3, I get 41 over 333. So 41 over 333 should work. Let's check it out. 41 divided by 333 gives me 0.123, and it repeats. So that is my answer. And if you're curious about this, now that I have it as a repeating decimal in here, I'll show you. If you multiply this by 1,000, the 123 moves in front, and you still have 123 repeating. Okay, that's it.